Welcome to Bethlahem Institute of Engineering. Bethlahem Institute of Engineering is affiliated to Anna University, Chennai and approved by AICTE, New Delhi. This institution was established in the year 2008.
Good morning students. Today we are going to discuss about Diffie Hellman key exchange. So this algorithm helps to exchange the keys secretly. So normally symmetric ciphers at the source side as well as at the destination side there should be the same key. Whatever may be the key they are using at the source, they have to use the same key at the destination also for encryption and decryption. At the source encryption, at the destination is decryption. So in order to encrypt and decrypt we have to use key. So normally we have to send the keys securely. Either the person at the source or at the destination, they have to communicate and they have to decide the key about the key in a secret way. So either they have to meet physically in a place and they have to exchange the keys. That will be difficult in sometimes. So we are having an algorithm called a Diffie Hellman key exchange algorithm. By using this algorithm you can exchange the keys. So this is the public key crypto system, public key encryption. That means the public key means at the source they have public key as well as private key, and at the destination also they have public key and private key, and the public key will be known to everyone, whether it is a source or destination. The public key will be maintained in a public key directory, and there you can find the public keys of all the users. So whoever may need the public key, they can get the public key from the directory. But the private key will be safe and secure. They have to keep the private key in secret. Okay, so this is a public key crypto system, and so here in Diffie Hellman we are exchanging a secret key by using this Diffie Hellman key exchange, and this is normally used in modern transaction also. This Diffie Hellman key is used. So the main use of this algorithm is to exchange the keys. Okay, exchange the key between source and destination, between two persons they want to communicate. So whoever want to communicate, then they have to use this public key. Public key system means this Diffie Hellman key exchange. Then so, and the value of this key depends on the participants. So they the source or destination, they can decide the key details about the key. So here in Diffie Hellman key exchange they are taking a prime number q. So q is a prime number, and alpha is also what is a primitive root of q. So q is a prime number and alpha is a primitive root of q. And from the user side they have to generate a key. So user here the communication between the user A and user B. Okay, the communication is between user A and user B. to transfer the key from to generate a key from the user side, user A side, they have to choose a private number XA. So you have to choose a private number XA, and the XA should be less than Q. So initially we took Q a prime number, and we have to select private number XA, that XA should be less than Q, and from this private key we can calculate the public key, and it is YA is equal to alpha power XA mod Q. So this is the formula for calculating a public key. Okay, from the user A, he can create the public key from this formula. So the person at the center side, or the sending side A, select the private key XA, and XA should be less than Q, and by using that private key we can calculate the public key YA is equal to alpha power XA mod Q. So you have to use the alpha and XA with the mod value Q. Okay, then from the at the user side B, he can also generate a public key by using by selecting a private key XB. So he can also choose a private key as XB. So by using that and also here also the XB also should be less than Q. The XB and the XA, the private key should be less than Q. So private key XB is selected from the user B, and he can calculate the public key YB is equal to A power XB mod Q. Okay, so the public key YB is equal to alpha power XB mod key. So XB is the secret key chosen by the user B, and XA is the secret key chosen by the user A. So from that only they can calculate the public keys. So here we have the public keys of A and B. So and in the user side A, he can calculate the secret key which he wanted to exchange. Is Here the formula is given, K is equal to the YB, the public key of the user B. So he have to use the public key of the user B, YB power XA. XA is the secret key of the user A. Okay, user A is itself his private key. Okay, X is a private key, so he can use this private key, and he can find out the secret key which he wanted to transfer between A and B. Okay, so the secret key K will can be calculated from YB power XA mod Q, YB power XA mod Q, and at the destination side, that means the user B, he can also calculate the secret key K is equal to YA power XB mod Q. So YA the public key of the user A, and XB the secret key of the user B mod Q. So here the at the user side A and B, they will both of them will have the same key. Okay, K. So K is same. The K value will be same at the source side as well as at the destination side. The key value will be same. Okay. So at the source side, that means at the user A end, the secret key can be calculated from the formula YB power XA mod Q. Here the YB is the public key of the user B, and XA is the secret key of the user A. And at the destination side, that means at the user B end, the key K is equal to YA power XB mod Q. YA power XB mod Q. Here YA is the public key of the user A, and XB is the private key of the user B. So here they will get the same key. K is same for both user A and user B. Here what happened is they are exchanging the key secretly. No one knows the K value K other than the user A and B. So here the pictorial representation is given. User A, he generate a random key XA, that means a private key, right? So which is less than Q, and calculate the public key YA. The formula is alpha power XA mod Q, and that YA value will be sent to the user B, and here user, because the public key is always publicly known, anyone can access the public key because it is available in the public key directory. So from there also any user can collect the public key of the any other user, so you can collect it from the public key directory. So the formula is YA is equal to alpha power XA mod Q. So after calculating, he is sending the public key to user B. So he, at the user B side, he also generate a random key XB, which is also less than Q, and he calculate the public key YB, which is equal to alpha power XB mod Q. YB, which is equal to alpha power XB mod Q, and he send the public key to the user A, and at the user A side, he can calculate the key K by using the formula YB power X mod Q. So here YB, you know, the public key of the user B, and X is the secret key of user A. So by using this formula, he can find the K value for user A, and user B side also, by using the public key of user A, he can calculate YA power XB mod Q. YA is the public key of the user A, XB is the private key of the user B. So here by using this formula, he can find the K value. Here both the K values are same. So indirectly user A and B have the same secret key. By using this key, they can encrypt the messages. Further messages can be encrypted by using this secret key K. So for further message transactions, they can use this K value, because the K value will be same for user A and user B. He can use this as K as a secret key. Here we can see an example. Users Alice and Bob, who wish to exchange keys. So they are agree on prime number Q, which is equal to 23, and alpha, which is equal to 5. So they are agree on the prime Q is equal to 23, prime number Q is equal to 23, and alpha is equal to 5. And at the user side A, he select the private key as XA is equal to 4, and at the user side B side, he chooses the private key as 3. So you know, as you know, XA is the private key of user A, and XB is the private key of the user B. So they are choosing the private key values, and the user A chooses the private value as 4, and user B chooses the private value 3. So that means XA is equal to 4 and XB is equal to 3. Okay, then by using these values, we can compute the public keys. So the formula, you know, as you know, YA is equal to the public key of A, which is equal to YA is equal to alpha power XA mod Q, alpha power XA mod Q. So alpha, we know the value as 5. So and xa value we know as 4. So 5 power 4 mod q value we know 23. So the formula becomes ya is equal to 5 power 4 mod q. So the formula becomes 5 power 4 mod q, which is equal to y, a, public key of a. So the public key of a is equal to 5 power 4 mod 23, and when you expand you will get 25 mod 23, which is equal to 4. So now the public key of a is 4, and we are next we are going to calculate the public key of b. The formula is alpha power xb mod q. So yb, the public key of b, which is equal to alpha power xb mod q. Alpha power xb mod q. Here we have the values of alpha and xb, which is alpha is equal to 5 and xb value is 3. So from that we can calculate yb, which is equal to 5 power 3 mod 23. 5 power 3 mod 23. 23, you know the q value. So the yb, public key of b, yb, which is equal to 5 power 3 mod 23, and we can expand like this, 125 mod 23, which is equal to 10. So now the public key of a is 4 and the public key of b is 10. So now these public keys are normally maintained in the public key directory, which can be accessed by any user, and it is publicly available. This is not a secret key, it is a public key. Public key means it's publicly available in the directory. Anyone want to communicate with any user, they can use this public key of that particular user. So the person A want to send the he can use the public key of b, yb, and by using that he can calculate the k value. The formula is k is equal to yb power xa mod q, and we know the yb value, xa values, we can substitute those values. So yb, you know the public key of b, which is 10, and xa, you know it's a private key of a. So the formula becomes 10 power 4 mod 23, which is equal to 18, right? So 10 power 4 mod 23, which is equal to 18, and at the destination side we can also calculate the k values by using the formula ya power xb mod q. We know the value of ya, which is the public key of user a. So we can substitute and the equation becomes 4 power 3 mod 23. 4 power 3 mod 23, which is equal to 64 mod 23, and again which becomes 80. Now you can see that the k values are same at the source as well as at the destination. You see k is equal to 18 at the source as well as k is equal to 18 at the destination. By using this values, 18 is now k, secret key is what, 18. By using this 18 they can send for encrypt the messages, further messages, and they can send and they can encrypt as well as decrypt by using this key. So we can see another one example also. Here also the user Alice and Bob want to communicate or exchange keys. So they agree on a prime number q is equal to 353 and alpha, which is equal to 3. They are selecting a random secret keys. Here the user A chooses the private key xa, which is equal to 97, and the user B chooses the private key xb, which is equal to 233, and they are going to compute the public keys. So for the public key of user A, ya is equal to alpha power xa mod q, and when you substitute, ya is equal to 3 power 97 mod 353, and finally he gets 40 as ya, public key of a, and yb, for public key of b, the formula is alpha power xb mod q, and yb is equal to 3 power 233, 2 power mm, 233 mode to 353, and he get the public key as 248. Now they can compute the secret key k for user a yb power x mod q, and which is equal to 248 power 97, which is equal to 160. Mod 353, which is equal to 160, and at the destination or the user b side, they can calculate the k value ya. K is equal to ya power xb mod 353, which is equal to 40 power 233, and the answer is what, 160. Here the k values, you can notice that the k value is same for user A as well as user B, is what, 160. Now by using this 160 as key, they can communicate, they can encrypt the messages as well as decrypt the message. So this is a very important use of this Diffie Hellman. So this Diffie Hellman algorithm is a public key crypto system. It uses a public key crypto. That means at the sender and receiver side, they will use two keys. One is private key and another one is a public key. So by using this algorithm, you can exchange the secret key between source and destination, and by using that key, they can send the remaining messages, encrypt or decrypt remaining messages by using the secret key. Here again we are going to see one example. Here user Alison Bow, who want to exchange messages, they agree on the prime number q23 and alpha is equal to 9, and they are calculating the secret key xa, which is equal to 4, and the secret key of b, user b, which is equal to 3, and from that they can compute the public key of a, which is equal to alpha power xa mod q to 99 power 4 mod 23, and which yields 6 as result, and you can calculate the public key of yb. The formula is alpha power xp mod q and 9 power 3 mod 23, which will get the result as 16, and from this they can calculate the secret key k, which is equal to yb power xa mod q, that means 16 power 4 mod 23, and he will get 9 as result, and at the receiver side ya power xp mod 23, that means 6 power 3 mod 23, he will get 9 as result. So this is the use of Diffie Hellman exchange to securely exchange keys between user A and user B. Thank you.